very important is that I'll start with very important quantity. It's called angular momentum. Now, can you drive angular momentum here? Here, linear momentum is written by P, let us say, which is equal to m into v. Okay. Here, angular momentum capital L is equal to I, because analogous of mass is I and velocity is omega. So, angular momentum is written as I omega. Now, let's try to break up this. Angular momentum is written by L is I into omega. I is m into r square into omega. I still break it. I write it m r omega into r, and I write it m into v into r. It is extremely important to say this. From this derivation, you can go from here to here also, or you can go from here to here. Both these questions, the equations are same. This tells you the angular momentum can be expressed in terms of linear momentum. How? You should know what is the mass of the body, velocity, this is the linear momentum, multiply this with the radius vector. If you multiply m and v, you will get linear momentum, but if you multiply m and v with r, you will get one more quantity, angular momentum. If you remember this angular momentum, we have told you in postulates, hydrogen Bohr's postulate, that angular momentum is quantized. If you remember, we have told you at that point, m v r is nh upon 2 pi. Do you know this thing?
Yes, sir.
This entire thing is the very important postulate of Bohr. mvr. Now I'll tell you one thing, try to understand. This is mass, and at a particular time we are talking, this is mass. This mass is rotating, and I have taken a photo, and it is rotating in radius mr. If I ask you what is the moment of the mass, moment of the mass is exactly m into r. If I ask you what is the moment of the angular momentum, what is the angular momentum at this time? mv1. Okay, mv1. Angular, I'm sorry. Linear momentum here is what? mv. This is mv. When you multiply this by r, it becomes moment of the linear momentum. So you have got one more definition of angular momentum. It's not a product of moment of inertia and this thing. Its angular momentum is also, can be said that it is moment of the linear momentum. Moment of the linear momentum. Because when you multiply any physical quantity with r, we call this as a moment. Right? And if you multiply F with r, moment of the force. Now there is a force acting on this, we'll talk about that. Force into r. This is called moment of the force. Moment of the force. When you multiply any quantity, what is the moment of the mass? M into r. So these are things which I am going to utilize. So this is called torque. I take this as a separately. This you have to see it. And if you, in place of F, you write from F, expression for F. F here is what? M into A. Here F is nothing but the torque. So this torque is tau. Tau is mass. Analogous of mass is I, and this will be alpha. So torque is I into alpha. So you can convert this into I into alpha. You can check it. Force is M into A. And what is M into A? Where is the first one? Oh, this is it. Now I will do this. So many things are together. So I just want to know what is the expression for tau. Force. In place of force, I write from here M into acceleration, M into A, and in place of R, I will write R only. Now I want to change this tau is here, I want to change this everything into rotational motion for physical quantities expressing rotational motion. So I will keep my M like this only. Instead of A, I can write, I am not written here. Yes, if you see from here, if you multiply, V is what? Again I have to draw this thing. If this is R, this is theta, d theta, and the body goes from here to here. This is L, distance from here to here is L, and this is dl distance. This angle is d theta. It goes from here to time d theta. Then you know there is a relation. What is the relation between L, R, and theta? L is R into theta. You know this is a basic equation.
Yes.
From here we know what is the definition of theta. Theta from here or d theta from here is this arc divided by this. This is a basic definition. If this arc is exactly equal to this, then theta is called 1 radian. If this is 3 centimeter, this is 3 centimeter, theta is called 1 radian. If this is 7 centimeter, this is also 7 centimeter, 7 by 7, 1, that is called 1 radian. And that will come nearly, how much is 1 radian equal to? Roughly 60 degrees, how many?
60.
Check it. Well, it just becomes like a quadrilateral, equilateral triangle. This, and if I take it extremely short distance, this curve will become just like a straight line, and it will become this thing, and this angle will automatically be equal to 60 degrees. So 1 radian is equal to or approximately equal to, check from the book exact value of this. Okay. Now if you differentiate this, you will get dl is equal to r into d theta. With respect to time, you differentiate this, you will get something like this. And dl by dl, linear distance upon time, is velocity r omega. This is one more relation between the angular velocity. All these quantities are related to r everywhere. You can check it. But only mass is related to I v square, mr square. So I'll see. So instead of A, you will write down what? Omega into R. And what is omega? I'll take it here. I write mr into omega. And what is this equal to? This whole thing is I omega. This is torque. In terms of quantities expressed in angular momentum. Moment of inertia multiply with angular
Moment.
Yes, it's okay. For example, torque is force, moment of the force, F into R. From here we have changed F into this into this. Then I got this expression and this expression. Rearranging R omega outside, we got this thing. So this you should learn that tau is expressed product of moment of inertia and the angular velocity. Here, I'm sorry. Something is happening wrong. Can anyone have to notice something here?
Sir, that
Yes, it has to be alpha. आप लोग घबराते ही क्यों यार? बोलिए आप. No, this is technical because I was thinking about something is happening wrong. So, tau this F into R, then we have converted into this and this. Moment of inertia into angular acceleration. These are two. So if you equate this with this, then can be numerical. They will give you the moment of inertia, they will give you the angular this thing, they will give you the radius also, and ask you what is the force acting on this. You can use directly, you can use indirectly. So this was something between the two. Now I like very. अच्छा मुझे इस पे एक और चीज याद आ गई which you should know. यहाँ बताना बड़ा relevant है ये. Since we were talking about the Bohr's model, we will tell you this is very important. If this is a nucleus, and which orbits are permitted, in which this is R, and this entire thing is 2 pi R. If this 2 pi R is L lambda, then this orbit is permitted. Now, if you combine this with this, you will get de Broglie's. What is that? Lambda is equal to h upon mv. You check it. So you should never forget this and this. It's very simple. Instead of take 2 pi from here to here, bring mv down, and then 2 pi is L lambda, and then you will get lambda is h upon mv. This is the proof of de Broglie equation also, and This, if you combine these two, you will get this. This is called quantization of orbit. Electrons cannot move in any random orbit in which we will move in such orbit in which the circumference 2 pi r is either 1 lambda, which is not possible, because for electron to have 1 lambda and equal to 1, lambda should be like this. Electron has to move through the nucleus, which is not possible. So what should be the minimum value of n? 2, 3, 4 onwards, and check it. 2. I think 2 it can be 2. We will see. Why it cannot be 1? Check from the books also. This is the nucleus, and electron is moving like this. It cannot move.
Yeah.
So not even 2 now.
Check it. Why? From here to here is 1. From here to here, it is 2. And I have taken 3. Check whether it is 2 or not. We try to draw. We will make a big orbit. From here to here 1. But at least n cannot be equal to. Have you understand what we are saying? Try to find out from the books what exactly its value is. Okay. So I'll stop here. Now I'll take the next one.